I hate chemistry.
Oh, no. You know we're going to study chemistry only in relation to A and P, right?
I know.
I don't like chemistry. No, I like chemistry, but not
It's
too
the
detailed.
formulas that make
Yes.
me want to rip my hair
Yes.
out and my brain explode.
Okay, so I told you that we are just made up of atoms. So that's why we have to know these different atoms. Right there, the different atoms over here. And so if you look at, where's chapter 2? Here you go. So, first of all, the reason why we need to study chemistry, because look at, biology is based on the principles of chemistry and physics. Oh, you're in the face. Are you 241? By 241? Okay. So I'm going to talk to you later. And so look at, we're made up of atoms. There's the different. You see, that's what you eat. Have you ever had a craving for something salty or something sweet? Then you eat it, right? You crave for something salty. You buy chips and then you say, I'm done. You eat maybe a few and then I'm done. You put it back in. Why? Because that is what you're made of. And if you're lacking in any of the ingredients, guess what? You're going to get sick. Okay? That's why, sometimes you don't feel right. You just feel like you're not feeling well. You schedule an appointment, you go have yourself checked, and then they say, did you have a breakup with your boyfriend? Maybe you're just not feeling well. No. At that point when you were not feeling well, you were not well. No one knows your body better than you. So if you don't feel well, you really were not well. You should say, thank goodness I am still okay. I am healthy to the point where I was able to correct that problem. So when I went to the doctor, I was able to fix my problem. But that's why I don't like, I used to not like it when they say, oh, everything normal, any problem? No, it's just that you were off. It's really because it's guided by physics. So we have to look at this because why? We're matter. Matter is anything that has weight and occupies space. So what is this matter made of? It's made up of all of these different atoms. Look at these atoms. Look at that. All of them unstable. All the atoms important to life, the atoms that we are made of, these major atoms, and you're not required to memorize them. This is not chemistry, right? But these are the atoms we're talking about. You see they have a number? You see that? Do you see number 11 anywhere else? No. If you see an atom floating around with a number 11, I know it's sodium. Does it make sense? If I see an atom that has number 6, that's carbon. There's nothing else here that's number 6. It's carbon. That's the name that it's given, carbon. What does this number mean? If we look at an atom, again, what is the atom? The atom is the smallest unit of matter that cannot be broken down any further. That's the smallest one. Carbon cannot be broken down further. If we look at the composition of this atom, it's made up of these subatomic particles called protons for positive charge, neutrons no charge, and electrons negatively charged. Look at the behavior of these subatomic particles. The protons and the neutrons are centrally located in a nucleus, they say. Its nucleus is always the center. So it's always in the center. Whereas the electrons, you notice, look at them. They're spread in an electron shell. But not all of them are spread in one shell. You see that? They are occupying a specific cloud because they follow what? The octet rule. Do you see that? So all the I know I'm made up of atoms. I'm made up of cells. And if I look at my cell, it's made up of this smallest unit called the atom. I look at this atom. Oh, it's made up of protons, neutrons, and electrons. How many many protons, neutrons, or electrons? Depends on the name. Okay? So let's say 11, that's sodium. So that means there are 11 protons and 11 electrons outside. Do you follow? Everybody? I can just plug all the protons and neutrons right there. But the electrons, that's the one that's the pain in the butt. Oh, not butt. The gluteal region. Right? That's the pain. Because the electrons, they don't just crowd outside. No, they have to occupy a shell. They follow a rule called the octet rule. Okay? Are you all following so far? Okay? One more time, I like to nag. That's what my husband, he won't get up until I tell him a million times, take the trash out. So the same way. I am made up of atoms, right? Centrally located protons and neutrons. The name of my atom depends on how many neutrons, protons, electrons I have, right? So we say 7 or 11. I look, that's sodium. You don't need to memorize this, okay? You don't need to memorize. I'm going to require you, though, to do some drawings of atoms and predict the type of bond that will result. So, knowing these atoms, there are some atoms here called inert, meaning they're stable on their own. They don't need the other atoms. You don't find that in your body. The atoms that we're made of are all unstable. They have to fulfill the octet rule. According to the octet rule, the first shell is stable if it has 2 electrons, and that's the maximum it can take. The second and all the succeeding shells after that are stable if they contain 8. That's why it's called octet rule. Do you follow? So, is this atom stable? No, because look at, how many does it need? 4 more, because it needs 8 octet rule. Okay? Let's say hydrogen, the atomic number is 1. So I know there's 1 proton inside, 1 neutron, and then 1 electron here. Is this stable? No, right? Because according to this octet rule, it needs 2. All the atoms, you see, that's why it's impossible for us to be stable. Eventually, you always have to reach for something because our atoms are unstable. We're made up of unstable atoms. That's why we behave the way we do. Okay? We always react. They're always trying to find a way to be stable. Do you follow? Does it make sense? Okay? Because of their very nature, they're all unstable. Their goal is to fulfill, to complete that shell. This is the reason why we worry, right? About free radicals or sun damage. Because what do these environmental factors do? They disrupt the stability that we have built in the body. You see? So again, I am just made up of atoms, and these atoms, I look at it, it's made up of protons, neutrons, electrons. Do you follow? You know what a proton is, what a neutron is, and what an electron is. Maybe I'll ask you that in the test. The smallest unit of structure is blank, made up of positively charged blank, negatively charged blank, and blank which carry no charge. You should know that. Okay? And so which of the 3 subatomic particles is the culprit for the unstable nature of the atoms that you find in your body? It is the electrons. They have to fulfill the octet rule. So here are a few atoms right here. You see, there's hydrogen, 1, unstable, needs 2. There's carbon, 6, unstable, 1, 2. So there's 4 in the outside. You need 4 more, all unstable. So, in reality, all the atoms in our body, they don't stay as atoms for a long time. Immediately, once they enter the body, immediately they find another one to be stable. So that process of finding another one is called chemical bonding. Does it make sense? Okay? Don't ask me why they're unstable. That's just the way they behave. They cannot stay like that. They always find a way to be stable. And if you inhale a free radical, let's say that free radical is unstable, it's going to destroy your blood vessels. That's how you end up with arteriosclerosis, because the atoms are unstable. You inhale, they're gonna, or you eat your free fatty acids, whatever, they're going to destroy. They want to be stable. Okay? And so they do that by chemical bonds. Do you follow so far? Everybody? Okay, why? They have to fulfill what rule? The octet rule. So what are these chemical bonds? There are three types of chemical bonds. The first is ionic bond. With an ionic bond, the electrons, it's either donated or accepted. Look at this. This is sodium. The atomic number, look at there, it's 11. So look, we don't forget in the test, I'm going to ask you, draw atom A with atomic number 11. Don't forget to write 11 protons inside and then 11 neutrons. Don't forget to write that one. Let me get a different marker. Okay. So don't forget, you need to write 11. So there's 11 protons, 11 neutrons, and then you spread out the 11 electrons. That's the thing. They occupy a specific cloud, okay? They have a maximum. For the first shell, it's stable and it can only accommodate 2. So 11 minus 2, you still have 9. So that 9, they go to the second shell, but the second shell can only accommodate 8, and that's it. It's stable at 8. So there's still 1. The 1 spills to the last. The last shell is referred to as your valence shell. Do you follow? So look at sodium. In this is the atom sodium. This is how it looks like. Is it stable? No. So what do you think? The way atoms behave, they behave in the most efficient way or the easiest way. What would be the easiest way for sodium to do? Would it be to get rid or find 7 more atoms, electrons somewhere?
Get rid of them.
Get rid. So look at it. It will get rid of it. So now look, when it got rid of it, it became, in this form, it's stable, isn't it? You see that? It got rid of the extra electron, so the extra electron is threw away. And now it becomes a charged ion. Why? The 11 protons stay in there, right? It's not, you don't bother the protons or the neutrons. It's just the electrons. Because it got rid of that 1 electron, so it will have 10 electrons here, but still 11 protons. So it's positively charged. Do you see that? So you call this a cation. You follow? Now let's look at this chlorine. So chlorine, atomic number 17. So 17 protons inside, right? 17 neutrons and 17 electrons outside. So we're going to distribute that. So 2 in the first, right? 17 minus 2, 15. You Put the 8 in the second shell, so there's 7 left. Put the 7 in the third shell. So in the valence shell, there's 7. Is this stable? No. So what's the efficient thing for chlorine to do? Just find 1 or donate 7. Find 1. So it can get 1 electron that was donated by sodium. Look at it. When it accepted an extra 1, this is now stable. The outside shell is now stable. The goal is for the outside shell to be stable. Now this one's stable, that one's stable, right? But this one carries an extra negative charge, right? Because it accepted an extra electron. Do you all get this picture? So you call this an ion. So you should know what a cation is and what an anion is. You get that? So, because this is positive charge and this is negative charge, you see them always combining. They're always attracted to each other. You form a salt. Okay? So that's why, they're easily dissolvable. That's your salt, right? Look at it. Sodium is gas. Chlorine is gas. You combine them, you form salt, your table salt. So chemical bonds, an ionic bond is a chemical bond that involves what? Donating and accepting an electron, forming a new compound. So now, this is stable, this is stable. But because they carry a charge, you always see them together. Where there's sodium, there will be chloride. They're always together. Positive and negative always attracted to each other. You follow? Okay? There's another type of chemical bond. No question on this one? So very easy, right? Again, I'm going to ask you, draw atom A with atomic number 11, let's say. Then draw atom B, atomic number 17. So be sure to write down the positive protons and neutrons here, then distribute your electrons in the shell. And then I will say, predict what type of chemical bond will happen between A and B or between A and C. Okay? So you should be very comfortable in drawing your atoms. The other type of bond is called covalent bonds. Covalent bonds are the most abundant type of chemical bonds in the body. Okay? And it makes sense. This is the most abundant and it is the strongest type of chemical bond. It makes a lot of sense because covalent means you're sharing. Like my daughter, I share it with my husband. I'm not going to let go. So there's stability in sharing. If you let go, you lose the stability. So I need to keep holding. That's why it's the strongest type of chemical bond. Whereas, look at the ionic bond, they just happen to be together. But individually on its own, look at, it's already stable. So this sodium can bind with bicarb, right? So whatever it sees there, it's easy to break it. But this covalent bond, it's not. It doesn't behave that way because they share. Okay, just like look at hydrogen. Okay, so this hydrogen, the atomic number is 1. So there's 1 electron there. It needs 1 more. If it finds another hydrogen, they can both share it, right? So you can't let go. If you let go, you become unstable again. So that's why it is the strongest type of bond. And this is the most predominant bond in the body. And there are 2 types of, do you follow? So what is covalent bonding? It's sharing. It's a chemical bond that involves sharing of electrons. Okay? Again, we're looking at the basic unit that the body is made of, every cell. It's called an atom. And we look at these atoms that you're made of. All these atoms that we have are unstable. Their goal is to be stable. They find a way. And they do that by chemical bonds. to fulfill the octet rule. The outermost shell has to be stable. Okay? So, there are, and we studied the ionic bonding. Now we're going to look at the covalent bonding. There are two ways to form a covalent bond. The first is the non-polar covalent bond, where there is equal sharing, just like the hydrogen, you see. They're sharing the electrons equally. In general, equal sharing happens between like atoms. There is also the unequal sharing called polar covalent bond. This is non-polar, this is polar. North pole and south pole, they are on opposite ends, so that's polar. Okay. And look at, it's generally between unlike atoms. How did that happen? Let's look at the, what's the atomic number for hydrogen? It's 1. How about for oxygen? 8. So at any point, oxygen will have 8 electrons, right? And there's only 1 electron here, right? And then there's also 8 positive protons here, 1 positive proton. Do you see? Okay. So when they're sharing the electrons, which one will have more of a pull? The electrons are negatively charged, right? Which one will attract the electrons more, the oxygen or the hydrogen?
Oxygen.
Yes, because it has 8 positive protons pulling the shared electrons. So even though this hydrogen and oxygen, they're sharing their electrons, it's unequal sharing. The electrons at any point are attracted more towards the oxygen atom than the hydrogen atom. Do you follow so far? It's just like my daughter, right? I share it with my husband, but Lily loves mommy more than, no, not loves, but Lily likes mommy more than daddy. So she comes to mommy more than daddy. But for playtime, she goes to daddy. But so you see, it's unequal, but it's a strong bond. We share it. You see that? Okay? So because of this polar covalent bond, we have the third type of chemical bond called hydrogen bonds. Did you get the definition of covalent bonds? Sharing, right? Sharing of electrons, either equally or unequally. Okay? Ionic bonds, what? Donating or accepting electrons, right? So, what did you write on covalent? You're also going to write it's the most abundant and the strongest. Very good. It's the strongest type of chemical bond. Look at this one with covalent. Hydrogen is gas. Oxygen is gas, right? Hydrogen gas, oxygen gas. You combine them, you have water. Completely different. The third type of chemical bond is called hydrogen bond. Of the 3 types, your covalent, ionic, and hydrogen bonds do not form a new compound. It does not. It lends to the strength and the shape of the compound. So you see, remember, this is water. There was unequal sharing, remember? The oxygen, the electrons are more attracted towards your oxygen oxygen atom, right? So the result, your hydrogen has a slightly positive charge and your oxygen has a slightly negative charge. Did you get that? Everybody? Okay? Yes, everybody? Okay. So because of that, the slightly positive hydrogen atom will be attracted to the slightly negative oxygen atom of the next water molecule. They hydrogen bond. But look at what is produced by hydrogen bond. Water hydrogen bonds with another water to produce water. You didn't make a new compound. It just lends to the strength of the compound. Okay? Again, why the chemical bonds? Because these atoms that were made up are unstable. They follow a rule called octet rule. It's the electrons that's the culprit. They will find a way to be stable, even if they are already stable in the body. Okay, I start my day, everything's stable, but then I drink my coffee, or I eat whatever. Maybe I eat a big chunk of pizza, let's say, right? Amino acids. You're breaking the bonds already. So you break the bonds. So you made an unstable environment. That's why we're busy. This is what you call homeostasis. This breaking bonds, forming bonds, breaking, forming is what you call metabolism. Okay? Do you follow? So again, hi, my name is so-and-so. I'm a living organism made up of atoms. Oh, by the way, my atoms made up of electrons, protons, and the electrons are unstable. They have to fulfill the octet rule. Okay? Every atom that I'm made of. And so, my atoms really don't stay atom for a long time. Don't stay atom at all. They form by chemical bonds called ionic. You know what ionic is. Covalent, you know what it is also. Or hydrogen bonds. And so I am going to modify my introduction. Hi, my name is so-and-so. I'm made up of molecules. Do you follow? Because atoms don't stay atoms for a long time. They always combine. So now we're going to look at our ingredients called molecules. So atoms, because they don't stay for a long time, they combine. This is a molecule made up of two atoms, right? So what are the molecules that each and every cell of my body contain? You group these molecules into two major groups called organic and inorganic compounds. You follow? Questions? No question? So, I think we will stop here.